All right, thank you, Cami. It's June 19th, 2025, and we're here to give a quick introduction of Veenster and Kim. I'll go over a background of our history with the city of Solon, and then we'll jump into the presentation. My name is Dave Scheckinger. I've been working with the city of Solon in various capacities, providing engineering services as the designated point of contact with V&K since 2000. B&K has been involved with water and sewer infrastructure, including wells, water storage, sanitary sewer construction, wastewater plant improvements, subdivision review, street improvements, and miscellaneous planning and city engineering tasks for over 25 years. We're very familiar with Solon and Eastern Iowa. Emily Linebaugh is with me tonight and has been working in Solon and other Eastern Iowa communities on water and wastewater treatment improvements for over 20 years. Emily was involved in the previous wastewater plant upgrade that has served the community over the 20-year design period. Let's get into the presentation and go over the background of why we're looking at a new wastewater treatment facility. The existing facility is located just off of Highway 382 on the western part of the city, and it is north of Mill Creek, south of Old Mill Creek subdivision. And we have several issues that surround that existing facility. The blue outline shows the area that encompasses the facility. To the north, there's a bedrock ledge. To the south is the creek. The creek floods occasionally, and when it does, it blocks the access road. We're also limited in how far south we can go because of that flooding. Easterly, northerly, and to the west, we have limitations with setback where we are not allowed to exceed certain setback distances. That limits how far we can build new improvements. And as you can see, the existing facility already has quite a bit built on it. To try to fit new improvements on that site would be very difficult, not only from a space constraint, but also just due to the existing piping, the way we would have to construct the facility to keep the existing one running, as well as a number of other challenges due to access and other issues. We have an existing facility that is made up of two oxidation ditches that were built in the 60s, and then the newer oxidation ditch that is smaller that was built in the 2000 era. We also have in the picture on the lower right a tank in the back that is our sludge storage tank. So once we go through this treatment process and there are biosolids that are waiting to be land applied, we hold them in that tank. There's a small digester located in the far background, and the top picture shows the main lift station. That lift station is limited in size, and we have pumps in there that are pretty much at capacity. And to try to do additional pumping in that location would be very difficult. We would be looking at building a new facility in that area. That existing wet well does not have any screening, and it creates a challenge for operations. The operators are required to use the red winch shown on that picture in the upper right to lift out a trash basket that catches any large debris that we want to keep from getting into the oxidation ditches. That's a very difficult and tedious manual process, and the new facility should have screening to avoid a lot of the issues that come from that. Emily, if you could go to the next slide, please. Some of the things that we take into consideration when we're planning wastewater treatment facility improvements are the growth areas. You can see from the small star on this picture, that is the existing facility. The green shaded area shows the area that existing facility can serve by gravity. The growth for the community, as seen on this map for future land use, is projected to go north, west, and there will also be growth out east near the golf course and likely to the south along Highway 382. The growth generally follows a pattern where existing utilities are able to serve the growth, so it would go from the existing community outward. Looking at the area that can be served by sewer, the western area is experiencing growth and could easily be served by gravity sewer through the Old Mill Creek area west, following the creeks that are shown on this drawing. What happens with the expansion is that we build out from the facility and we try to drain in by gravity. So we would have to construct sewer and build outward. We could build where the big red star is and flow by gravity to collect the smaller red star, which is the existing facility. And that was taken into consideration when we're looking at new sites. The site has to be away from existing development so we can meet the site separation requirements. And it also has to be set up so that it can serve future expansion. The area with the red star is shown on the next slide. Emily, if you could go to that. And that is south of Oakland Cemetery. And you can see the existing facility highlighted in blue. If we construct a trunk sewer along the creek that heads west towards Lake McBride, we could pick that up at that new facility and also go north along the east side of Trail Ridge development. That area is very appealing when we look at new sites for wastewater treatment because of the ability to surf gravity to all those locations that would potentially develop. We also have a very large open area there that would allow for future expansion. The decision to go from the existing facility west to the new facility has to be made at some point because that existing facility would eventually fill up. Knowing that there are significant challenges, not only with access, but with the age of the facility, the city has looked very closely at the two options and has identified the new facility at the location of the large red star as the preferred alternative to take on the needed improvements now rather than continuing to try to add to the existing facility, knowing that at some point that has to be abandoned and we would need to build an entirely new facility in the future. So the red star location is where we would look to build the new facility. And Emily will get into some of the specifics of what is required in the analysis and the design of the new facility.
Thanks, Dave. So the new facility, as part of the design, looks to project a minimum of 20 years out into the future, and we actually are projecting to the year 2050. So we are trying to go from 20 years into the future from when the plant would actually go online. As you can see from this data, existing flows to the plant, the population is roughly 3,400 people in 2023, so it may actually be even a little higher than that now. We have approached the existing plant capacity. In some areas, we are actually exceeding the existing plant capacity. So when we project out 20 years, we've used growth rates similar to surrounding communities, in this case, projected similarly to the community of North Liberty, and are looking at a population of roughly 10,000 in the year 2050. In order to serve that population, we would be looking at an average daily flow of almost 1 million gallons per day. And for a facility, the average wet weather 30 that's highlighted there in the gold box is what's considered the treatment capacity of a plant. It represents the wettest 30 days that the plant will see. And the facility here is 1.363 million gallons per day with a peak hour flow of 4.7 million gallons per day. Also, when you size a plant, you would also be looking at the organic loading, which is a combination of BOD, TKN, and a few other items that you'll see on the screen there. The probably the most important thing to recognize in this is that this plant will be over 1 million gallons per day, and that will trigger it being considered a major facility for the state of Iowa. And with that also comes the requirement to meet nutrient removal limits of nitrogen and phosphorus that the plant currently does not have to meet. In order to meet the new limits as well as size for the future growth, we're required to look at alternatives as part of EPA's requirements. These alternatives we must justify the degradation that will occur by discharging additional pollutants to the stream based on quantity and also the fact that we're relocating the discharge point with a future plant. As part of this alternatives analysis that we're required to do, we have to look at non-degrading alternatives as well as a base pollution control alternative and then less degrading alternatives. The six alternatives that were considered for this facility include recycle reuse, land application of the wastewater, regional treatment to another facility potentially that already has capacity, the new Aeromod treatment facility, a new carousel treatment facility, and a new carousel treatment facility with flow equalization. The first three items or first three alternatives on this list are considered non-degrading, which means that they do not affect the creek that would potentially be a discharge. Recycle, reuse, land application, and regional treatment were all considered not feasible for this location and were eliminated from consideration and further development. Of the remaining three alternatives, we looked at each of the three degrading alternatives, and we'll go into that in a little more detail here. Each of those three alternatives are part of a type of facility called a mechanical plant. The general concept of a mechanical plant is to provide treatment of the wastewater through screening, grit removal, then adding aeration basins, typically activated sludge plants, and then to clarifiers, and finally through disinfection and discharge to the creek. As you can see here, we have a diagram kind of illustrating the normal flow path through a plant that I highlighted there. Um, we also have some examples of screens that could be implemented, as well as um, a grit removal system and also the disinfection. Each of those alternatives that we mentioned before utilize that general mechanical plant concept and do it in a little different way. Alternative 4, which is the Aeromod treatment facility, is laid out on the new facility site that Dave discussed earlier. And in this facility, we would be flowing from the new trunk sewer that Dave discussed that flows from the existing plant site through pumps, screens, and grit removal, and then over to an Aeromod tank that is shown there on the right that is illustrates that the aeration basins, clarifiers, and also digestion for sludge treatment are all share common wall construction. And then we would also have additional biosolids storage, and a dewatering building ahead of that so that we could handle the solids that are generated as part of the removal of the pollutants. We also, on that site, are able to allow space for future expansion, which is a key component of moving to the new site so that we are giving ourselves room to expand. The cost of doing an alternative for Aeromod treatment facility, when all added together, the estimated construction cost is $29.3 million roughly, with a total project cost of roughly $36 million. Alternative 5, which is the carousel treatment facility, is also a mechanical plant and follows the same general process. However, it approaches it slightly differently in that the aeration basins are separate from the clarifiers and also utilize a proprietary process that really goes to how they achieve the nutrient removal as well as handling the aeration with propellers as opposed to utilizing a diffused aeration system. The same advantages on this plant are shown on the facility layout. The plant additionally provides some benefit in that it is similar in operation to the oxidation ditch and clarifier layout at the existing facility. So staff would be more familiar with the process. The cost of this facility, when added up with each individual component, ends up being $29.6 million with for estimated construction costs, with an estimated total project cost of $36.5 million roughly. The last alternative that was considered was a carousel treatment facility with flow equalization. And this slide here helps illustrate the additional utilization of the existing facility site to simply store any wastewater flows above the peak hour and above the plant capacity at the existing site with minimal improvements necessary. Otherwise, it is the same facility that was shown in the earlier alternative 5 layout at the new site. But this would allow us to, I guess I would say, trim the flows back and maybe utilize some of the equipment at the new site, bring that down in size just a slight bit. It also allows for us to a little more flexibility in operations with a minimal increase in cost. As you can see here, the estimated construction cost is 29.9 million with an estimated project cost of 36.8 million roughly. Our recommendation after completing the analysis was to recommend alternative 6, which is the carousel treatment facility with flow equalization. The main reasons we recommend this facility is that it meets the standards and provides nutrient removal, including nitrogen and phosphorus that are new to the city of Solon due to the size of the facility. It also provides a process similar to what the current facility utilizes, but also improves the screenings, grit removal, is able to do nutrient removal, and also provides solids handling improvements. The equalization component allows for peak flow reduction and accommodation of more flow range. Due to the nature of the existing facility, it is difficult to accurately estimate a peak flow, so this will give us some buffer for any underestimation or potentially future increases in I&I that tend to happen as systems age. And then finally, this new facility allows us for expansion and also some operational flexibility. Looking ahead, the project timeline, the anti-degradation analysis was actually approved as of June 2025, and we will be submitting the facility plan to the Iowa DNR in the next month and be looking also to fund these improvements with an application for the state revolving fund. The design of the new wastewater facility improvements should be occurring from July of 2025 through January of 2027, with anticipating bidding the project in February of 2027. The construction of a facility of this size is anticipated to take approximately 2 years, with the completion for the facility improvements and the facility online by June of 2029. With that, we'd like to thank you for joining us today.
Just going to check and see if there's anybody online that has any questions before we close the presentation. All right, seeing none. Thank you very much, everyone. Have a good evening.